Let's detail the subproblem definition we proposed. We have a parameter I, which corresponds to the prefix length. I is going to vary between 0 and n. I equals 0 corresponds to the empty string. I equals n corresponds to the original input. Now we're going to define a function L of I. This will be the length of the longest common subsequence in a prefix of x of length I and a prefix of y of length I. So x1 through xi and y1 through yi. Note this is analogous to the original problem except on a prefix of the input. One other notable difference, this does not store the subsequence itself, it simply stores the length. We want our table to store our number or true-false. Now let's take a look back at our earlier example. Now this was our earlier example. We're trying to find a recursive relation for L of I. We're trying to express L of I in terms of smaller subproblems, L1 through Li minus 1. Let's try to gain some insight from this example. In order to get a smaller subproblem, we're going to look at the last character. So we're going to look at xi and yi. We're going to look at how xi and yi are used in the solution to L of I. And then we can use the solution to the subproblem of size I minus 1. We take the optimal solution for the subproblem of size I minus 1, and then we append on the solution for xi and yi. Now there are two cases to consider. Either these last characters are different, in this case, or they're the same. We're going to consider these two cases separately. The first case is when the last characters, xi and yi, are the same. The second case is when the last characters, xi and yi, are different. We're going to do this case first. xi equals yi. The last characters are the same. This turns out to be the easy case. Now let's modify our example so that the last characters are the same. So I append on character c onto the end of both strings. Now in this case, where the last character is the same, what do we know about the longest common subsequence? Well, we know it must end in this common character. Why? Well, give me a common subsequence, and suppose it does not include this last character. Well, then I can append on this common character, and I get a longer subsequence. So therefore, the longest common subsequence must include this last character. So in this case, where xi equals yi, what do we know about L of I? We know that the longest common subsequence includes this last character, so we get 1 in the length for that common character. And then we can simply drop this last character, and then we can take this input sequence of length I minus 1. And we can take the longest common subsequence in this input sequence of length I minus 1 and append on this common character c. What is the length of the longest common subsequence in this input? It's simply L of I minus 1. So we have a recursive relation. We can express L of I in terms of L of I minus 1. This handles the case when xi equals yi. Now let's take a look at the case when xi is not equal to yi.